There is a distance in the universe that almost nothing actually sits at, yet it quietly shapes nearly everything we know about the stars. A distance so oddly defined that even many astronomy enthusiasts feel a subtle confusion when they hear its name: the Parsec. Tonight, we begin with a simple but unsettling question. Why does this strange unit exist at all? And why did it become so important that modern astronomy cannot function without it? Because the deeper you follow this story, the more it feels like a quiet paradox hidden inside the structure of science itself. A measurement built not from nature, but from the way humans chose to observe it. And once you notice that, it changes how you see the entire cosmos. Here on Velarin's Sleepy Space Mysteries, we often explore these quiet contradictions of space, like in our earlier journey into the hidden geometry of black holes, where reality bends in ways that feel almost impossible to imagine. And just like that story, tonight's mystery begins with something small, almost invisible, yet powerful enough to reshape our understanding of everything beyond Earth. To understand the Parsec, we have to travel back to a time when humanity had no idea how far away the stars were. For thousands of years, they appeared fixed, unmoving, like tiny lights embedded in a perfect celestial sphere. There was no depth, no distance, only a flat illusion stretching across the night sky. But hidden within that stillness was a subtle clue, a tiny shift that only becomes visible when you change your perspective. This shift is called parallax, and it is the key to everything that follows. Imagine holding out your hand and looking at your thumb, first with one eye closed, then the other. Your thumb seems to move slightly against the background. That small shift is your brain measuring distance. Now imagine doing the same thing. But instead of your two eyes, you use Earth itself, moving from one side of its orbit to the other. Suddenly, the scale becomes unimaginable, and the shift becomes almost impossibly small. Yet within that tiny movement lies the first true measurement of the stars. And this is where the mystery deepens. Because instead of defining distance in a simple, intuitive way, astronomers chose to define it based on that tiny angle. Not the distance itself, but the geometry used to find it. The Parsec was born not as a natural boundary in space, but as a byproduct of observation, a unit created from perspective rather than reality. So tonight, as we slowly drift deeper into this story, keep one question quietly in your mind. What does it mean when the universe is measured not by what it is, but by how we look at it? If you find yourself enjoying these calm explorations of cosmic mysteries, consider subscribing, leaving a like, and turning on the notification bell so you don't miss future journeys. You can also support the channel through membership if you'd like to go deeper into these stories. And before we continue, let me know in the comments where you're watching from tonight. There's something quietly beautiful about knowing that while we explore the vastness of space, we're all listening together from different corners of Earth. Now, let's return to that tiny shift, the almost imperceptible motion that took centuries to detect. Because understanding the Parsec means understanding just how difficult it was to measure distance in the first place. For most of human history, the stars refused to reveal their secrets. No matter how carefully astronomers watched the sky, the constellations never seemed to change. night after night, year after year, century after century. The stars held their positions with perfect stillness. It was as if they were painted onto the sky itself, unmoving and unreachable. This illusion was so convincing that ancient civilizations believed the stars were fixed to a solid sphere surrounding Earth. Not because they lacked intelligence, but because every observation supported that idea. There was no visible shift, no measurable motion, nothing to suggest depth. And without movement, there could be no distance. But everything changed when astronomers realized something subtle yet profound. Earth itself is moving. As it orbits the sun, it creates a natural baseline, a way to observe the same star from two different positions in space. 6 months apart, Earth stands on opposite sides of its orbit, separated by hundreds of millions of kilometers. This creates a kind of cosmic double vision, allowing astronomers to detect that tiny shift, the parallax. In theory, it sounds simple. Observe a star in one season, observe it again half a year later, measure the angle of its shift, and calculate the distance. A clean geometric solution, elegant, almost obvious. But in reality, it was one of the hardest measurements ever attempted. Because the shift is not just small, it is unbelievably small. So small that even the most advanced instruments of the early telescopic era simply couldn't detect it. The atmosphere blurred the stars. Mechanical vibrations distorted measurements. Even temperature changes could alter the shape of a telescope just enough to ruin precision. The signal astronomers were searching for was buried beneath layers of noise far larger than the effect itself. This is where the story becomes almost meditative, a lesson in patience and persistence. For decades, scientists tried and failed. Some believed they had succeeded, only to realize later they had measured something else entirely. Others spent years observing, only to find nothing at all. The universe remained silent, offering no easy answers. And yet, the question never disappeared. How far away are the stars? It lingered quietly, pulling astronomers forward generation after generation, until finally, one observer approached the problem differently. Instead of trusting a single measurement, he accounted for every possible source of error: temperature, pressure, mechanical flexure, even the subtle bending of light through Earth's atmosphere. He didn't just observe the sky. He studied the imperfections of observation itself. And in doing so, he uncovered something extraordinary. Not a dramatic shift, not a clear movement, but a tiny, delicate pattern. A slow, almost invisible oscillation traced over the course of a year. A star moving, ever so slightly, against the distant background. For the first time in human history, the distance to a star had been measured. But this is where the quiet strangeness returns. Because instead of expressing that distance in something intuitive, like kilometers or even light years, astronomers defined a new unit based entirely on that angle. A unit that didn't correspond to any physical boundary in space. A unit that no star naturally aligns with. A unit born purely from the act of measurement. The Parsec. And as we continue, we'll begin to uncover why this seemingly awkward choice became one of the most powerful tools in all of astronomy. If you pause for a moment and really sit with this idea, it begins to feel almost quietly strange. That one of the most important distance units in science was not chosen because it reflects something natural in the universe, but because it makes a calculation easier. The parsec is not a distance you would ever discover just by observing space itself. There is no boundary, no transition, no hidden structure that suddenly appears at exactly 1 parsec. Instead, it exists because of a simple relationship between an angle and a baseline. And that relationship, while elegant, reveals something deeper about how humans interact with the cosmos. To understand why astronomers embrace the parsec so completely, we need to slow down and gently revisit that geometric idea, not as a formula but as a story. Imagine once again that triangle stretching across space. At one corner sits Earth, at another corner sits the Sun, and far away at the tip, a distant star. As Earth moves along its orbit, that triangle shifts ever so slightly, changing the angle at which the star is seen. Now here is the key moment. Instead of asking, "How far is the star?" astronomers asked a slightly different question. At what distance would that angle become exactly 1 arcsecond? That question defines the parsec. It is, in a sense, a distance created by reversing the problem. Instead of measuring distance directly, we define a distance where the geometry becomes simple. If the shift is 1 arcsecond, the distance is 1 parsec. If the shift is smaller, the distance increases in a perfectly predictable way. And suddenly, something remarkable happens. The math becomes effortless. A star with half an arcsecond of parallax is simply 2 parsecs away. A star with a quarter of an arcsecond is 4 parsecs away. The relationship is so clean, so immediate, that it feels almost like a shortcut through complexity. And this simplicity mattered more than anything else. Because for the astronomers of the 19th and early 20th centuries, calculations were not done with computers. Every number was written by hand. Every conversion introduced a chance for error. Every extra step slowed the process. So a unit that allowed distance to be calculated instantly, just by inverting a number, was not just convenient, it was transformative. It turned a difficult, error-prone process into something almost intuitive. But this convenience came with a quiet cost. Because while the parsec is perfect for calculation, it is not intuitive for human imagination. When you hear that a star is 10 parsecs away, it does not immediately evoke a feeling. It does not connect to anything in everyday experience. Unlike a light year, which tells a story about time and the journey of light, the parsec remains abstract, rooted in geometry rather than narrative. And yet, despite this, it spread through astronomy with remarkable speed. By the late 1800s, more and more stars had measured parallaxes. Distances began to fill notebooks, catalogs, and research papers. And almost without any formal decision, astronomers began using parsecs everywhere. It was simply easier. One by one, researchers adopted it not because they were told to, but because it made their work smoother, clearer, and faster. It became a kind of silent agreement across the scientific community. And this is where the story begins to expand beyond individual stars. Because once you have a reliable way to measure nearby distances, you can begin to build outward. One measurement supports the next like stepping stones extending into the dark. Nearby stars help calibrate more distant ones. Patterns emerge. Relationships form. Slowly, a ladder of distance begins to rise, each rung reaching farther into space. This is known as the cosmic distance ladder. And at its very base, at the very first step, sits parallax. And because parallax naturally produces distances in parsecs, every rung above it inherits that same unit. It becomes the foundation not just for measuring stars, but for measuring galaxies, clusters, and eventually the structure of the universe itself. So what began as a simple geometric convenience quietly became the backbone of cosmology. And if you listen closely, there is something almost poetic in that. The vast scale of the universe, billions of galaxies, trillions of stars, distances beyond comprehension, all trace back to a tiny angle measured from a moving planet by observers who refused to accept that the stars were forever out of reach. But the deeper mystery still lingers, because if our understanding of the universe is built on this ladder, and that ladder begins with a unit defined by human perspective, then how much of what we call reality is shaped by the way we choose to measure it? As we continue, we'll follow this ladder upward beyond nearby stars, into the realm where distances stretch into millions, and then billions of parsecs, where the quiet simplicity of this unit begins to reveal its true power and its subtle limitations. As we gently climb higher on this invisible ladder of distance, something subtle begins to shift in our understanding. At first, the parsec feels like a tool designed only for nearby stars, a neat solution to a difficult geometric problem. But as astronomers continued to observe the sky, they realized something unexpected. The same logic that worked for nearby stars could be extended, step by step, into the deep universe. Not directly, but through a chain of careful connections. And this is where the story becomes quietly fascinating. Because beyond a certain distance, parallax no longer works. The angles become too small, too delicate to measure, even with the most precise instruments. The tiny shift that once revealed distance simply fades into stillness again. It is almost as if the universe returns to that ancient illusion, a flat, unmoving sky. But this time, astronomers were no longer limited by what they could see directly. Instead, they began to use patterns hidden within the stars themselves. One of the most important of these patterns came from a special kind of star, one that does not shine steadily, but pulses, slowly, rhythmically, like a distant heartbeat. These are known as Cepheid variable stars. And what makes them extraordinary is not just that they vary in brightness, but that the timing of that variation reveals something deeper. The longer a Cepheid takes to brighten and dim, the more luminous it truly is. This relationship is precise and reliable. It means that if you observe one of these stars and measure how long its cycle lasts, you can determine how bright it actually is, not just how bright it appears. And once you know that, you can compare it to how dim it looks from Earth and quietly infer its distance. No parallax required, just light, time, and careful observation. But here is the crucial connection. This entire method depends on calibration. You must first know the true distances to a few nearby Cepheids in order to understand the relationship between their period and luminosity. And those initial distances come from parallax, which means they are measured in parsecs. So even as we move beyond the reach of direct measurement, the parsec remains embedded in every calculation. It becomes the hidden language beneath the method, the quiet foundation supporting everything above it. And from here, the ladder continues. Cepheid stars allow astronomers to measure distances to nearby galaxies, stretching the scale from thousands of parsecs to millions. Within these galaxies, new patterns emerge. Entire systems of stars, moving together, forming structures far beyond anything previously imagined. What once appeared as faint, blurry patches in the sky are revealed to be vast collections of billions of stars, each one separated by immense distances, yet bound together by gravity. And then, another step. In the most distant galaxies, astronomers observe something even more dramatic: stellar explosions known as supernovae. These events briefly outshine entire galaxies, releasing enormous amounts of energy in a short time. And among them, a particular type stands out for its consistency. These explosions reach nearly the same peak brightness every time, making them powerful markers of distance. By comparing how bright these supernovae appear to how bright they are known to be, astronomers can estimate distances across unimaginable scales, hundreds of millions, even billions of parsecs. And at this point, something profound emerges. The parsec, once a small, local unit tied to a subtle angle in the sky, has expanded to describe the structure of the entire observable universe. It has grown through prefixes kiloparsecs, megaparsecs, gigaparsecs, each step multiplying the scale, each layer revealing a deeper level of cosmic structure. Galaxies are separated by millions of parsecs. Clusters of galaxies span tens of millions. The vast web-like structure of the universe stretches across billions. And yet, the definition remains the same, still rooted in that tiny angle, still tied to Earth's orbit, still connected to a simple geometric idea conceived long before computers, satellites, or modern cosmology. There is something quietly humbling about that, because it means that when astronomers map the universe, when they describe the expansion of space, when they measure the distance to galaxies at the edge of visibility, they are still, in a sense, relying on the same foundational concept that once revealed the distance to a single nearby star. But as we reach these enormous scales, another layer of mystery begins to appear. Because the farther we look, the more we begin to see that distance itself is not as simple as it first seemed. Space is not static. It is expanding. Galaxies are not just sitting in place. They are drifting away, carried by the stretching of space itself. And this raises a quiet, unsettling question. What does distance really mean in a universe that is constantly changing? When we say a galaxy is millions or billions of parsecs away, are we describing where it is now, or where it was when the light began its journey? Are we measuring space or time? These questions do not have simple answers, and they begin to blur the line between observation and interpretation, between measurement and meaning. So as we continue this journey, we move from geometry into something deeper, into the evolving nature of the universe itself, where the parsec is no longer just a unit of distance, but a key to understanding how space, time, and light are woven together. And in the next part, we'll begin to explore how this quiet unit becomes essential in describing one of the greatest discoveries in modern science, the expansion of the universe itself. As we move deeper into this quiet expansion of understanding, the parsec begins to reveal something unexpected, not just about distance, but about motion itself. Because once astronomers could measure how far away galaxies were, a new question naturally emerged. Are those galaxies standing still, or are they moving? At first, this might seem like a simple question, but the answer reshaped our entire understanding of the universe. When astronomers began studying the light from distant galaxies, they noticed something subtle. The light was stretched, shifted slightly toward the red end of the spectrum. This effect is known as redshift, and it carries an important meaning. When light waves are stretched, it suggests that the source of that light is moving away from us, not through space in the usual sense, but because space itself is expanding. And here is where distance and motion become deeply connected. The farther away a galaxy is, the faster it appears to be moving away. This relationship is not random. It is precise, predictable, and universal. Double the distance, and the speed of recession doubles as well. This simple pattern became one of the most important discoveries in modern science, often referred to as the expansion of the universe. But to describe this relationship, astronomers needed a consistent way to measure distance across enormous scales. And once again, the parsec quietly took its place at the center of everything. Because when you express distance in megaparsecs, millions of parsecs, the relationship becomes clear and manageable. Astronomers can say that for every megaparsec of distance, a galaxy's recession speed increases by a certain number of kilometers per second. This value is known as the Hubble constant, and it acts almost like a cosmic ruler linking space and motion together. So now, the parsec is no longer just a unit of distance. It becomes part of an equation that describes how the universe evolves. And this is where the mystery deepens once more. Because even with all our precision, all our measurements, all our advanced instruments, different methods of calculating this expansion rate do not fully agree. Some measurements suggest a slightly slower expansion. Others suggest a faster one. The difference is small, but significant enough to challenge our understanding. This tension, often called the Hubble tension, is one of the most intriguing puzzles in cosmology today. And at its core, once again, lies distance. If our measurements of distance are even slightly off, everything built on top of them shifts as well. The expansion rate changes. The age of the universe changes. Our entire cosmic timeline begins to bend. So the parsec, which began as a simple geometric convenience, now sits quietly at the heart of one of the greatest unsolved mysteries in science. There is something almost poetic about that. A unit defined by a tiny angle, influencing our understanding of the largest possible scale. But as we continue to reflect on this, another layer begins to emerge. because the parsec also highlights a subtle difference between scientific precision and human intuition. In professional astronomy, parsecs are everywhere. Every dataset, every catalog, every equation relies on them. They are efficient, consistent, and deeply integrated into the structure of research. But outside of that world, in books, documentaries, and conversations, a different unit takes over: the light year. And this contrast reveals something important about how we communicate the universe. A light year tells a story, connects distance to time. When you hear that a galaxy is millions of light years away, you are also hearing that its light has been traveling for millions of years. You are looking into the past. The concept feels immediate, almost tangible. But the parsec does not tell that story. It remains quiet, technical, abstract. It belongs to calculation, not imagination. And yet, despite this, it endures. Not because it is easier to understand, but because it is easier to use. And this brings us back to the question we carried from the beginning. What does it mean when the universe is measured not by what feels intuitive, but by what makes our calculations simpler? Perhaps it reminds us that science is not just about discovering truth, but about building systems that allow us to approach that truth more clearly. The parsec is one of those systems, a tool shaped by human choices, yet powerful enough to map the cosmos itself. And as we move toward the final part of this journey, we'll begin to slow down, to step back from the measurements, the equations, the scales, and reflect on what this all means. Because beyond the numbers, beyond the units, beyond the vast distances, there is something quietly profound about the fact that from a small planet orbiting an ordinary star, we have found a way to measure the universe at all. And that may be the most mysterious thing of all. And so, as we reach the final stretch of this part, everything begins to settle into a quieter perspective. The equations fade into the background. The measurements become softer, less urgent. And what remains is something more reflective, a sense of scale that is almost impossible to hold in the mind, yet strangely calming when you stop trying to fully grasp it. Because the parsec, for all its technical origins, ultimately tells a very human story. It begins with uncertainty, with generations of observers staring into the night sky, seeing no depth, no distance, only points of light that refuse to move. It continues with persistence, with countless failed attempts, careful refinements, and the slow realization that the universe does reveal its secrets, but only to those willing to measure with patience beyond ordinary limits. And then, finally, it arrives at something unexpected. A unit of distance that does not emerge from nature itself, but from the act of observation. A distance defined not by where something is, but by how we see it from where we stand. There is something quietly profound in that idea, because it reminds us that every measurement we make is shaped by perspective. The baseline we choose, the angle we observe, the tools we build, even something as vast and objective as the universe becomes, in a small way, filtered through the methods we use to understand it. And yet, despite this, the results are astonishingly consistent. From that tiny parallax shift, measured with immense difficulty, we built a ladder that reaches across galaxies. From that simple geometric idea, we mapped structures billions of parsecs away. From that one quiet definition, we found a way to describe the expansion of space itself. It is almost as if the universe allows itself to be understood through these small openings, these narrow windows where geometry, light, and motion align just enough for meaning to emerge. But as we reflect on this, another thought begins to form. What if the strangeness of the parsec is not a flaw, but a clue? A reminder that the universe does not organize itself according to human intuition. That the structures we find most natural, like distance measured in kilometers or time measured in years, are not the structures the cosmos necessarily follows. Instead, we uncover patterns that feel indirect, even awkward at first, but reveal deeper consistency once we accept them. The parsec is one of those patterns. It feels strange because it is not designed for storytelling. It does not translate easily into everyday experience, but it aligns perfectly with the geometry of observation, and that alignment gives it power. And perhaps that is the quiet lesson hidden within this entire journey. That understanding the universe is not always about finding the most intuitive explanation, but about finding the one that works, the one that connects observations in the simplest, most reliable way, even if it feels unfamiliar at first. So as you drift through this thought, imagine once more that tiny angle, 1 arcsecond, barely perceptible, almost invisible. Imagine the Earth moving slowly around the Sun, tracing out its orbit. And imagine a distant star, so far away that its motion is almost imperceptible, yet just enough to reveal its distance. From that delicate alignment, the parsec emerges, not as a boundary in space, not as a natural landmark, but as a bridge between observation and understanding. And as we move into the next part, we will begin to slow even further, to step away from the technical layers and explore what all of this means on a more human level. Because when you think about it, the fact that we can measure such distances at all, from a small, quiet planet orbiting an ordinary star, is itself one of the most extraordinary mysteries in the universe. If you're still listening, gently let me know by commenting 1. Just a small signal, like a distant star, that you're still here, still drifting through this vast and quiet story with me. Now, as we drift into the next part of this journey, something begins to change, not in the universe itself, but in the way we experience it. Up until now, the parsec has been a tool, a method, a quiet framework that allows astronomers to measure distance with precision. But beneath that technical layer lies a deeper realization, one that slowly emerges when you stop focusing on the numbers and begin to feel the scale behind them. Because what the parsec truly reveals is not just how far things are, but how separated everything in the universe really is. Imagine for a moment the nearest star beyond our sun. It sits just over 1 parsec away. In cosmic terms, that is incredibly close, almost touching. And yet, even at this close distance, the gap between stars is so vast that light itself takes years to cross it. Not seconds, not minutes, but years. A beam of light, moving faster than anything else in existence, must travel for years just to bridge that smallest of interstellar gaps. And this is where the quiet weight of the parsec begins to settle in, because it reminds us that space is not crowded. It is not dense or tightly packed. It is mostly empty, profoundly, overwhelmingly empty. Stars are scattered like distant islands in an endless ocean, each separated by distances so large that even our fastest technology barely begins to approach them. But here is where the story becomes more subtle, because while these distances feel isolating, they also create structure. The parsec is not just a measure of emptiness. It is a measure of how the universe organizes itself. Stars cluster into groups, groups into galaxies, galaxies into vast cosmic webs. And each of these structures exists at scales that can be described quietly and consistently using this same unit. It is almost as if the parsec acts like a hidden rhythm beneath the universe, a way of spacing things out just enough to allow complexity to emerge. And yet, when we bring this back to a human perspective, something else begins to unfold. Because every measurement we've discussed, every star, every galaxy, every distant structure has been observed from a single point, Earth, a small planet orbiting a relatively ordinary star, located in the outer regions of a spiral galaxy. All of our understanding of cosmic distance begins here, anchored to this one moving platform. And that introduces a quiet kind of fragility into everything we measure, because the entire concept of parallax, the very foundation of the parsec, depends on Earth's motion. If we were somewhere else in the galaxy, orbiting a different star, the baseline would change. The angles would shift. The measurements would be slightly different. The unit itself would still exist, but its meaning would feel subtly altered. So in a sense, every parsec carries with it a trace of Earth's journey around the Sun. It is not just a universal unit, it is also a local one. And this is where the mystery becomes more philosophical, because it raises a question that sits quietly beneath all of astronomy. How much of what we measure is truly universal? And how much is shaped by where we happen to be? The universe, after all, does not come labeled with units. It does not prefer kilometers, or light years, or parsecs. These are tools we created, ways of translating something vast and complex into something we can work with. And yet, despite being human-made, they allow us to uncover patterns that appear consistent across billions of light years. That balance between human perspective and universal truth is one of the most fascinating aspects of science. And the parsec sits right at that intersection. It is both arbitrary and essential, both abstract and deeply practical, a unit that feels unintuitive, yet unlocks clarity at every level of observation. But as we continue, another layer begins to emerge, because the more precisely we measure distance, the more we begin to notice something unusual. Small discrepancies, tiny mismatches between different methods. At first, they seem insignificant, just minor uncertainties in measurement. But over time, as instruments become more precise, those small differences begin to stand out. They do not disappear, they persist. And this suggests something important, that even with all our tools, all our units, all our careful calculations, we may still be missing something. So as we move forward, we'll begin to explore these subtle inconsistencies, not as errors, but as clues. Because sometimes the smallest mismatches in measurement are the first signs that something deeper is waiting to be discovered. And just like the tiny shift that first revealed the distance to the stars, these small differences may lead us toward an even greater understanding of the universe. As these small discrepancies begin to emerge, they do not announce themselves loudly. There is no sudden contradiction, no dramatic collapse of understanding. Instead, they appear quietly as tiny differences between methods that should, in theory, agree perfectly. A distance measured using one technique comes out slightly larger. Another method suggests something slightly smaller. At first, these differences are easy to dismiss. After all, every measurement carries uncertainty. No instrument is perfect. No observation is completely free of noise. But over time, something unsettling becomes clear. The differences remain. Even as telescopes improve, even as satellites rise above Earth's atmosphere, even as measurements become more precise than ever before, the gap does not disappear. It sharpens. It becomes more defined. And slowly, astronomers begin to realize that they are not simply looking at random error. They are looking at a pattern. This is where the story gently reconnects to something we touched on earlier, the expansion of the universe. Because one of the key ways we measure that expansion depends on distance. And not just any distance, but distances built upon the cosmic ladder, step by step, beginning with parallax, and therefore with parsecs. One method uses the nearby universe. It starts with parallax, calibrates Cepheid variables, and then uses those Cepheids to measure distances to galaxies. From there, it extends outward using supernovae. This method builds upward from the bottom, from what we can measure directly. Another method looks in the opposite direction. It studies the cosmic microwave background, the faint afterglow of the early universe. By analyzing patterns in that ancient light, astronomers can infer how fast the universe should be expanding today, based on a model of how it evolved over time. And here is the quiet tension. These two methods, one rooted in nearby measurements, the other in the distant past, do not quite agree. The difference is small, only a few %. But in science, especially at this level of precision, that difference matters. It suggests that something, somewhere in our understanding, may be incomplete. And once again, distance sits at the center of the mystery. If the distances measured using parsecs are slightly off, even by a small amount, that error would ripple upward through the entire cosmic ladder. Every step would shift. Every derived value would change. The expansion rate would adjust. The age of the universe might need revision. But if the distances are correct, then something else must be responsible. Perhaps our models of the early universe are missing a subtle piece of physics. Perhaps dark energy behaves differently than we expect. Perhaps there is an unknown component influencing cosmic expansion, something we have not yet detected. And so, what began as a question about a strange unit of distance quietly evolves into one of the deepest mysteries in modern cosmology. It is almost poetic, a unit defined by a tiny angle, leading us toward questions about the fate of the entire universe. But as we sit with this, there is another layer worth noticing, because the parsec itself has not changed. Its definition remains clear, stable, and precise. The geometry still works. The relationship between angle and distance still holds. The unit is not flawed. What is uncertain is how we apply it. And this distinction is important, because it reminds us that science is not just about tools, but about interpretation. The same measurement can lead to different conclusions depending on the framework used to understand it. The parsec gives us distance, but what that distance means in a dynamic, expanding universe is something we are still learning. And this brings us back once again to perspective. The parsec is rooted in observation from Earth, from a moving platform orbiting a star. But the universe we are trying to describe is far larger, far more complex, and constantly evolving. Bridging that gap between local measurement and universal truth is one of the greatest challenges in science. Yet, despite all this complexity, something remarkable remains. We can still measure. We can still observe. We can still detect patterns in the light of distant stars and galaxies, and from those patterns, we can infer distances that stretch across billions of parsecs. Even if some details remain uncertain, the overall structure holds together. The universe is not chaotic or unknowable. It is structured, consistent, and quietly revealing its secrets, one layer at a time. And perhaps that is the most comforting realization in all of this. That even when our understanding is incomplete, even when small discrepancies appear, the act of measurement itself continues to guide us forward. So as we continue into the next segment, we will begin to slow our pace slightly, not to lose depth, but to gain clarity. Because beyond the equations and uncertainties, there is something else waiting to be understood, something more reflective. Not just how we measure the universe, but what it feels like to exist within it. And as we gently slow our pace, letting the technical layers soften into the background, a different kind of understanding begins to take shape. One that is not driven by precision, but by perspective. Because beyond the calculations, beyond the instruments, beyond even the concept of the parsec itself, there is a quieter realization waiting to be noticed. We are measuring something we can never physically reach. Every distance we have discussed, every parsec, every megaparsec, every vast stretch between galaxies, exists far beyond any journey we can currently imagine completing. Even the nearest stars remain separated from us by distances that would take thousands of years to cross with our fastest machines. And yet, despite this, we have found a way to map them, to describe them, to understand their positions in space with remarkable clarity. There is something almost dreamlike about that, because it means that our knowledge of the universe is not built on travel, but on light. We do not go to the stars to measure them. Instead, we wait, we observe, we collect the faint signals that arrive after years, centuries, or even millions of years of travel. And from those signals, we reconstruct distance, motion, and structure. The parsec, in this sense, is not just a unit of distance. It is a measure of separation between observer and source, between here and there, between now and then. And that last distinction begins to matter more and more as we look deeper into space. Because when we observe distant galaxies, we are not seeing them as they are today. We are seeing them as they were when their light began its journey. A galaxy 1 million parsecs away is also being seen as it existed millions of years ago. A galaxy billions of parsecs away is a glimpse into a universe that existed billions of years in the past. So distance becomes something more than spatial. It becomes temporal. Every parsec carries with it a delay, a quiet stretching of time between the moment light was emitted and the moment it is received. The farther away something is, the deeper into the past we are looking. And this transforms the act of measurement into something almost like archaeology. A study not just of where things are, but of how they once were. And this is where the emotional weight of the parsec begins to emerge. Because when you imagine a distant star, you are not imagining a present reality. You are imagining a memory carried by light. That star may have changed, evolved, or even disappeared entirely by the time its light reaches us. Yet in our observations, it remains preserved in the moment its light began the journey. So in a quiet way, the universe we observe is not a single moment in time, but a layered tapestry of many different moments, all arriving together. Nearby stars show us the recent past. Distant galaxies reveal ancient history. The deeper we look, the further back in time we travel. And the parsec, though it appears to measure only distance, is quietly guiding us through this journey across time. But as we reflect on this, another thought begins to form. Because if every observation is delayed, if everything we see is already in the past, then the present universe, the universe as it exists right now, is something we can never directly observe. It exists beyond our reach, hidden behind the finite speed of light. And yet, we can still understand it. Through patterns, through models, through careful inference, we reconstruct the present from the past. We take the distances measured in parsecs, combine them with the behavior of light, and build a picture of how the universe must be evolving right now. This is one of the most remarkable achievements of science. Not just that we can measure the universe, but that we can understand something we cannot directly see. And all of this returns us once again to that original idea. A tiny angle, a subtle shift, a measurement so small it once seemed impossible to detect. From that beginning, we built a system capable of reaching across billions of parsecs, connecting observation to understanding, distance to time, and geometry to the structure of reality itself. So as you sit with this thought, imagine the night sky once more. The stars appear still, quiet, unchanged, just as they did for ancient observers thousands of years ago. And yet now, hidden within that stillness, you know there is motion, distance, time unfolding across unimaginable scales. The sky has not changed, but the way we see it has. And perhaps that is the deepest mystery of all. Not that the universe is vast, but that we have found a way to perceive that vastness at all. As this realization settles in, something within the experience of distance begins to soften. It is no longer just about numbers stretching into infinity, or units scaling from parsecs to megaparsecs to distances that feel almost abstract beyond comprehension. Instead, it becomes something quieter, something more personal. Because when you think about it carefully, every distance we measure is, in a sense, a relationship. Not just between objects in space, but between us and the universe itself. The parsec, though it seems technical and distant, is actually rooted in connection. It begins with Earth, with our motion, our orbit, our perspective. It extends outward to a star, a faint point of light that shifts ever so slightly against a distant background. That shift is not just a measurement, it is a relationship between observer and observed, a subtle dialogue between motion and light. And as that relationship scales outward, it never truly disappears. Even when we measure galaxies billions of parsecs away, the connection remains. The light from those galaxies still travels across space to reach us. The measurement still depends on how that light is received, interpreted, and understood. The universe does not simply exist out there. It exists in interaction with observation. This idea becomes even more meaningful when we consider how fragile that connection is. If Earth did not orbit the Sun, parallax would not exist in the way we use it. If light did not travel at a finite speed, distance would not carry the same meaning. If the universe did not follow consistent physical laws, none of these measurements would hold together. Everything we have built, every parsec, every model, every cosmic map, depends on a delicate balance of conditions that allow observation to translate into understanding. And yet, those conditions do exist, quietly, consistently across billions of years, which suggests something deeply comforting, that the universe, despite its vastness, is not indifferent to understanding. It behaves in ways that allow patterns to emerge, measurements to align, and meaning to be extracted. The parsec is one small expression of that larger truth, a sign that even at enormous scales, the universe remains accessible to careful observation. But as we reflect on this, another thought begins to take shape. Because if our understanding is built on these relationships, if distance is something we infer through interaction, then perhaps the universe is not just something we observe, but something we participate in. Not in a mystical sense, but in a subtle, physical one. Our position, our motion, our instruments all influence how we perceive the cosmos. The baseline of Earth's orbit becomes part of the measurement. The sensitivity of our detectors shapes what we can see. Even the limitations of our perception guide the questions we choose to ask. So in a quiet way, the act of measuring distance is also an act of defining our place within the universe. The parsec, then, is not just a unit. It is a bridge, connecting a small planet to distant stars, linking local motion to cosmic structure, tying human curiosity to the vastness of space. And as we continue to follow this thread, something else begins to emerge, something almost paradoxical. Because the more precisely we measure distance, the more we realize how little we can physically reach. The clearer the map becomes, the more distant its destinations feel. The parsec gives us clarity, but it also reminds us of separation. And yet, that separation does not feel empty. feels filled with light. Every star we measure, every galaxy we observe, sends something toward us. Not matter, not physical presence, but information. Light carries patterns, spectra, subtle variations that tell us about composition, motion, temperature, and history. Through that light, the universe communicates, and the Parsec helps us interpret that message. It tells us how far the signal has traveled, how long it has taken, how much the universe has changed during that journey. It adds context to observation, turning raw data into understanding. So distance, in this sense, is not just separation. It is storytelling. Each parsec adds a layer to the narrative. Each measurement places an event within a larger timeline. Each observation becomes part of a continuous unfolding, a story written not in words, but in light and space. And as we move toward the final segment of this part, we begin to slow even further, allowing these ideas to settle into something calm, almost meditative. Because beyond the complexity, beyond the calculations, there is a simple truth waiting to be felt, that from where we are, from this small, quiet world, we have found a way to listen to the universe across unimaginable distances. And in doing so, we have become part of its story. And now, as we arrive at the final stretch of this part, everything begins to quiet even further, not in the sense of losing depth, but in the sense of settling into something more still, more reflective. Because after everything we've explored, the geometry, the measurements, the expansion of the universe, the subtle tensions in our understanding, what remains is something surprisingly simple. The parsec is a way of knowing without touching. It allows us to reach across distances that we will likely never physically cross, and yet still build a meaningful picture of what exists there. It transforms light into distance, motion into structure, and observation into understanding. And in doing so, it reveals something not just about the universe, but about us. Because we are a species that measures. We look at the sky and we do not accept mystery as a stopping point. Instead, we lean into it. We ask questions, build instruments, refine our methods, and slowly, patiently extract meaning from what at first appears unreachable. The parsec is one of the quiet results of that process. Not a dramatic discovery, not a sudden revelation, but a careful, thoughtful solution to a problem that once seemed impossible. And yet, even with all of this progress, something remains beautifully incomplete. Because no matter how precisely we measure distance, no matter how many parsecs we map, the universe always extends beyond our current reach. There are always stars too far, galaxies too faint, regions too distant for even light to have reached us yet. The observable universe itself has a boundary, not because space ends, but because light has not had enough time to travel farther. So in a quiet way, every measurement we make is also a reminder of what lies beyond. And perhaps that is what gives the parsec its deeper meaning. It is not just a tool for defining what we know, but also a marker of what we do not yet know. Each parsec measured is a small step into the unknown, a point of clarity carved out of vast uncertainty. And when you imagine this on the largest scale, it becomes something almost poetic. A growing map expanding outward, illuminated not by exploration in the traditional sense, but by understanding carried through light. But as we sit with this idea, there is one final shift in perspective to consider. Because throughout this entire journey, we have spoken about distance as something external, something out there in the universe. But the moment you reflect more deeply, you begin to realize that distance is also something internal, something experienced. Parsec is not just a number. It is the difference between seeing a star as a point of light and understanding it as a distant sun. It is the difference between a silent sky and a dynamic universe filled with motion, history, and structure. It is the space between perception and comprehension. And once that shift happens, the night sky is never quite the same again. Those small, steady points of light no longer feel fixed or flat. They begin to carry depth, layers of distance stacked across space and time. Some are relatively close, just a few parsecs away. Others lie hundreds, thousands, even millions of parsecs distant. And all of them are connected through the same quiet framework. The same geometric idea that began with a tiny shift observed from Earth. So as you imagine the sky now, perhaps lying still, listening quietly, letting your thoughts drift, consider how much is hidden within that stillness. Distances so vast they stretch beyond intuition. Light traveling across years, centuries, millennia. Structures forming and evolving across scales that feel almost timeless. And yet, all of it can be measured. All of it can be understood, at least in part, through something as simple and as strange as the parsec. And as we move forward into the final part of this journey, we will allow everything to slow even further, to gently transition from understanding into reflection. Because beyond the science, beyond the measurement, beyond even the mystery, there is something deeply calming about realizing that the universe, in all its vastness, can still be quietly known. If you're still here, still drifting through this calm exploration, gently let me know by commenting too. Just a small signal across the quiet distance that you're still listening. And now, as we enter the final part of this journey, everything begins to slow. Not because there is nothing left to explore, but because what remains is no longer about discovery. It is about reflection, the kind that settles gently, like starlight arriving after a long journey, carrying with it not urgency, but quiet meaning. Because when you step back from everything we've uncovered, the parsec is no longer just a unit of distance. It becomes something softer, almost symbolic, a reminder that even the most abstract ideas can bridge the gap between the human mind and the vastness of the universe. Think again about where this all began. Tiny shift, a nearly invisible motion, something so small that for thousands of years it went completely unnoticed. And yet, hidden within that subtle movement was the key to unlocking the scale of the cosmos. Not through force, not through exploration in the physical sense, but through patience, observation, and a willingness to look just a little closer than anyone had before. There is something deeply calming in that idea, because it suggests that understanding does not always come from reaching farther, but from seeing more clearly. The parsec, in its quiet way, represents that clarity. It takes something vast and distant and translates it into something measurable, something consistent, something that fits into the framework of thought. It does not make the universe smaller, but it makes it more knowable. And yet, even as it does this, it never removes the sense of wonder. Because no matter how many parsecs we measure, no matter how precise our maps become, the universe always stretches beyond them. There is always more space, more time, more light still traveling toward us from regions we have not yet seen. The map is never complete, and perhaps it is not meant to be. This is where the experience of distance becomes something almost meditative. You begin to realize that the numbers themselves are not the point. The parsecs, the megaparsecs, the immense scales, they are not there to be fully grasped or held in the mind all at once. Instead, they act like gentle markers, guiding your awareness outward, allowing you to sense the vastness without needing to fully contain it. And in that sense, distance becomes something you feel rather than something you calculate. A quiet expansion of perspective, a soft awareness of how far things truly are, and how remarkable it is that we can know that at all. Because at the center of all of this is still Earth, still moving quietly around the sun, still tracing out that baseline that makes parallax possible, still serving as the reference point from which all these measurements begin. Every parsec we define carries within it that motion, that orbit, that subtle shifting perspective. So even as we speak about distant galaxies and cosmic expansion, there is always a connection back to something small and familiar. A reminder that our place in the universe, though physically small, is not insignificant. It is the point from which understanding begins. And perhaps that is what makes this entire story feel so peaceful. Not just that the universe is vast, but that it is accessible. That from where we are, with the tools we have, with the light that reaches us, we can slowly, gently uncover its structure. We do not need to rush. We do not need to reach the edge. It is enough to observe, to measure, to understand a little more with each step. And as we continue, we will let that feeling deepen, allowing the story to settle into something even quieter, something closer to stillness, where the vastness of space no longer feels overwhelming, but simply present. And as that stillness deepens, something subtle begins to shift in the way we hold these ideas. The universe no longer feels like something distant that must be understood through effort, but something that can be gently experienced through awareness. The parsec, once a technical concept, begins to dissolve into the background, leaving behind a quieter impression, a sense of spacing, of vastness, of calm separation between things that do not need to rush toward one another. Because in the universe, nothing feels hurried. Stars form slowly over millions of years. Galaxies drift and evolve over billions. Light travels patiently, crossing immense distances without urgency, simply moving forward at its constant pace. And within that slow unfolding, the parsec becomes less about measurement and more about rhythm, a rhythm of distance, a quiet spacing that allows everything to exist without collision, without chaos, without crowding. Stars are not packed tightly together. They are given room to shine, to evolve, to move along their paths without interference. Even galaxies, vast as they are separated by enormous stretches of emptiness, like islands floating in a calm, endless ocean. And this spacing is not accidental. It is part of what allows the universe to be stable, to develop structure, to create the conditions where complexity can emerge. If everything were closer, interactions would be more violent, more chaotic. If everything were farther, structure might never form at all. Somewhere within this balance, this quiet spacing measured in parsecs and beyond, the universe finds its harmony. And as you sit with that idea, it begins to feel less like an abstract concept and more like something familiar, because spacing exists in our own experience as well. Moments between thoughts, pauses between breaths, silence between sounds. These small gaps are what give shape to everything else. Without them, experience would blur into something overwhelming, something indistinct. It is the spaces in between that create clarity. In a quiet way, the parsec is like that, but on a cosmic scale. It defines the space between stars, the distance between galaxies, the separation that allows light to travel, information to move, and time to unfold. It is not something we see directly, but something we feel through its effects, through the calm structure of the universe itself. And perhaps that is why, even though the parsec feels unintuitive at first, it becomes natural over time. Not because it aligns with everyday experience, but because it aligns with the deeper patterns of observation. It fits the way the universe reveals itself, slowly, subtly, through relationships rather than absolutes. But as we continue to drift through this thought, another layer begins to emerge. Because the parsec also reminds us of something else, something quietly grounding. That no matter how vast the universe becomes in our understanding, we remain here, within it, not outside of it. We are not observers looking in from a distance. We are part of the same structure we are measuring. The same physical laws that govern distant galaxies also shape the atoms within us. The same light that travels across parsecs eventually reaches our eyes, becomes signals in our minds, and forms the thoughts we are now experiencing. So the act of measuring the universe is not separate from the act of being in it. It is part of the same process. And this realization softens the sense of distance even further. Because while stars may be separated by parsecs, and galaxies by millions more, the light that connects them also connects to us. There is a continuity, a quiet thread running through everything, from the most distant regions of space to the present moment of awareness. And in that sense, distance is not just separation. It is connection across time. Every parsec is a path that light has traveled. Every measurement is a recognition of that journey. Every observation is a meeting point where something distant arrives here, now, quietly completing its long passage through space. So as we move toward the final segments of this journey, allow that idea to settle. That the universe is not just vast, but gently connected. That distance is not just emptiness, but the space through which light carries meaning, and that even something as abstract as the parsec can lead us toward a deeper sense of calm, of perspective, and of place within the cosmos. And as this feeling of connection settles more deeply, the universe begins to feel less like an overwhelming expanse and more like a quiet presence, something that surrounds, supports, and unfolds at its own gentle pace. The parsec, which once seemed like a strange and abstract construct, now fades into the background, not disappearing, but becoming part of a larger awareness. Because what it truly represents is not distance alone, but proportion. A way of understanding how things relate to one another across scales so vast that they would otherwise feel impossible to hold in the mind. Without such a framework, the universe would remain a blur of incomprehensible magnitudes. But with it, even the largest structures begin to take on a kind of soft clarity. You begin to sense where things are, not precisely, not mathematically, but intuitively. Nearby stars, a few parsecs away, forming a loose neighborhood around our sun farther out. Clusters of stars, thousands of parsecs across, gently orbiting within the galaxy. Beyond that, the Milky Way itself, stretching tens of thousands of parsecs, a vast spiral quietly rotating over immense spans of time. And beyond even that, other galaxies, separated by millions of parsecs, drifting slowly as space itself expands. Each layer builds upon the last, each distance adding depth, not confusion. And within that layered structure, there is a kind of calm order, a sense that the universe is not random, but organized in a way that allows it to be gradually understood. But perhaps the most peaceful realization comes when you stop trying to picture all of it at once. Because the universe is not meant to be held entirely in the mind. It is too vast, too layered, too continuous for that. Instead, it can be experienced in moments, in small glimpses that gently expand your perspective without overwhelming it. A single star in the night sky, a faint glow of the Milky Way stretching overhead, a distant galaxy captured in a telescope image. Each of these is a doorway, a small window into something much larger. And behind each of those windows lies distance measured in parsecs. Yet you do not need to calculate those distances to feel their presence. You only need to recognize that they exist, that the light reaching you has traveled far, that it has taken time, that it carries with it a story that began long before this moment. And that realization, quiet as it is, creates a sense of depth that transforms even the simplest view of the sky. It is no longer flat. It is no longer still. It becomes layered, alive with motion and history, gently unfolding across space and time. And as you continue to sit with this awareness, something else begins to soften. The sense of separation. Because while distances in the universe are immense, they are not isolating in the way they might first seem. The same physical laws apply everywhere. The same patterns repeat across different scales. Stars form in similar ways. Galaxies evolve through familiar processes. Light behaves consistently no matter how far it travels. There is unity within the vastness. a quiet consistency that connects distant regions of space to the place where you are now. And this unity makes the distances feel less like barriers and more like expressions of structure. The parsec, in this sense, is not dividing the universe into separate parts. It is describing how those parts are arranged within a coherent whole. And perhaps this is where the deepest calm emerges, not from trying to understand everything, but from realizing that everything fits together, even if we only see a small part of it at any given time. The universe does not need to be fully known to be meaningful. It only needs to be gently observed. And as we approach the final segment of this journey, we will allow that observation to become even quieter, even softer, letting the ideas settle into a calm reflection that does not ask for answers, but simply rests in the awareness of what has been revealed. Because sometimes understanding is not about reaching a conclusion. It is about finding a place where curiosity can rest and simply be still. And now, as everything continues to slow, the need to understand begins to gently dissolve into something softer. The questions that once guided us, what is a parsec, why does it exist, how does it shape our view of the universe, no longer feel urgent. They have done their work. They have opened the door. And now what remains is simply the quiet experience of standing within that understanding, without needing to push it any further. Because in the end, the parsec is not something you need to hold tightly in your mind. It is something you can let drift. A quiet reminder that distance exists, that space stretches far beyond what we can see, and that light, patiently traveling across that space, carries with it the story of everything it has touched. You do not need to calculate those distances. You do not need to remember exact numbers. It is enough to feel the scale, to sense that the universe is vast, and that somehow you are aware of that vastness. And that awareness is already something extraordinary. Because when you look up at the night sky, what you are really seeing is a collection of journeys. Light leaving distant stars, crossing parsecs of empty space, arriving here quietly, without announcement. Some of that light began its journey before recorded history. Some before entire civilizations existed. Some before humanity itself. And yet, it arrives, softly, constantly, without effort. And in that arrival, there is a kind of calm continuity. The universe does not rush its processes. It does not demand immediate understanding. It unfolds at its own pace, and we, in our own way, learn to match that pace, to observe, to reflect, to slowly build meaning from what we receive. The parsec, though defined through geometry, becomes part of that rhythm. It marks the scale of these journeys, the quiet distances that light must cross. But more than that, it reminds us that understanding often comes not from speed, but from patience, from allowing observations to accumulate, from letting patterns emerge gradually, from accepting that some answers take time, sometimes years, sometimes generations. And there is something deeply peaceful in that idea, because it aligns with the way the universe itself behaves. Nothing is rushed. Stars take millions of years to form. Galaxies evolve over billions. Light travels steadily, never accelerating, never slowing, simply continuing forward. And in that steady motion, there is no urgency, only continuity. So as you sit with this, perhaps listening quietly, letting the words drift past without needing to hold on to each one, imagine that same steadiness extending outward. Imagine the light from distant stars continuing its journey, crossing vast distances measured in parsecs, moving through the quiet darkness of space. No sound, no resistance, just motion, and eventually arrival, here, now. And in that moment of arrival, something subtle happens. Distance becomes connection. What was once far away is now present, not physically, but perceptually. The journey is complete, and in its completion, it becomes part of your awareness. A distant star, separated by unimaginable space, becomes something you can see, something you can think about, something you can gently understand. And that transformation, from distant to present, is one of the quiet miracles of observation. The Parsec helps describe that journey, but the experience itself goes beyond measurement. It becomes something almost meditative, a reminder that even across vast separation, there are pathways, threads of light that connect distant points in the universe, allowing them to be known, even if they can never be reached. And as we move into the final segment, we will allow everything to settle completely, to rest in that awareness without needing to add anything more. Because sometimes, the most complete understanding is not something that expands endlessly, but something that gently comes to rest, leaving behind a sense of calm, of perspective, and of quiet connection to the vast universe that surrounds us. And now, as we reach the final moments of this journey, everything becomes still. Not empty, not silent in the absence of meaning, but gently quiet, like the universe itself when you stop trying to measure it and simply allow it to exist around you. The ideas we followed, the geometry, the distances, the strange elegance of the Parsec, begin to soften, like distant stars fading into the horizon of thought. Because in the end, the Parsec was never meant to be something you memorize. It was a doorway, a way of stepping beyond the illusion of a flat sky into a universe filled with depth, with layers, with distances that stretch far beyond anything we can physically reach. And now that you've stepped through that doorway, there is nothing left to prove, nothing left to calculate, only something to feel, the quiet awareness that above you and around you, space extends outward in every direction. Not crowded, not chaotic, but gently open. Stars separated by parsecs, galaxies drifting across millions more, light traveling patiently through it all, connecting distant points across time. And within that vastness, there is no urgency. Everything moves at its own pace. The stars do not rush to shine. The galaxies do not hurry to collide. Even light itself, though it moves at the fastest speed possible, feels calm in its journey, because the distances it crosses are so immense that time stretches into something almost peaceful. And somehow, you are part of that, not separate from it, not observing from the outside, but here, within it, on a small world that orbits quietly, creating that tiny baseline that gave rise to the Parsec in the first place. That small motion, that subtle shift, became the key that allowed us to understand the scale of everything beyond. And that is something worth sitting with, because it means that even the smallest movements, the smallest perspectives, can open the way to understanding something vast. You do not need to travel across parsecs to connect with the universe. You only need to look, to notice, to allow your awareness to extend outward just a little, and recognize that every point of light carries with it distance, time, and a story that has traveled far to reach you. And as you rest in that thought, the need to define those distances fades. It is enough to know they exist, enough to feel that the universe is deep, layered, quietly unfolding beyond the limits of sight. The parsec remains there in the background, still doing its work, still shaping the way we understand the cosmos. But for now, it can simply rest as part of a larger awareness that no longer needs explanation. Because understanding has already happened, not as a set of facts, but as a shift in perspective. The sky is no longer flat. The stars are no longer fixed. Distance is no longer abstract. Everything has depth. Everything has history. Everything is gently connected through light, through motion, through the quiet geometry that began this entire journey. And as the thoughts begin to slow, becoming softer, more distant, like the stars themselves, there is one final reflection to carry with you, that in a universe measured in parsecs, in distances so vast they stretch beyond imagination, there is still a place for stillness, a place where you can simply exist, aware of the vastness, without needing to hold it all at once. A place where curiosity does not need to push forward, but can rest gently within what has already been discovered. So as you drift now, perhaps preparing to sleep, let the universe remain as it is, vast, quiet, unfolding, and know that somewhere out there, across distances measured in parsecs, light is still traveling, slowly, steadily on its way to somewhere else, just as it once arrived here. If you're still listening, still here in this quiet moment, gently let me know by commenting 3, a small signal across the distance, that you stayed with the journey all the way to the end.